Awesome. Thanks everyone who stayed for my part. So I'm going to be talking about trustworthy tests for an AI future. Was anybody at last month's Lean Agile Edinburgh? That is good because 60% of this is recycled content. 40% of it is brand new, and see if you can figure out which files. But basically, I subtitled this Fast Restoration, Less Clicking, and Less Clicking Rerun. And the general idea is that as we move towards this new way of building software, we're going to have to change how we test it. And there's a lot of reasons for that, and that's what we're going to kind of dive into in today's session. So, quick introduction. This is me. As of a week and a half ago, I'm head of engineering performance at a company called Exclaimer. Before that, I was at a scale-up called Continuum Industries, and before that, I spent about 10.5 years in Skyscanner. Basically, my role is to help engineering organizations, product organizations to work as effectively and efficiently as they can. Anybody who's worked in a slightly larger company, they're up to early needs of 50 people plus, you'll be used to the bureaucracy and there's other problems and challenges that often creep in. It's basically my job to try and make sure that those things don't happen and to make sure that we can get as much done as we possibly can. And as you can imagine with that, obviously AI is a really interesting thing for me because all I have to do is spend 30 seconds on LinkedIn and I'll find claims of companies going 100 times faster, 10 times faster, 50 times faster, etc. I don't really believe any of those hyperbolic claims, but I think there is definitely some truth in AI being pretty transformative for how we build software. Not standing alongside me this evening, but somebody who has stood alongside me for the last couple of years and has been instrumental in putting together not just the slides for this, but some of the underlying sort of content we're going to talk through, is Alakbar. Alakbar is a senior software engineer currently doing freelance work, so I just want to make sure he gets this sort of due credit for this as well. Today we're basically going to talk about three things. First of all, why the existing testing approaches are basically insufficient for this way forwards. Secondly, understanding why there's kind of problems and why they actually exist. And then thirdly, we're going to talk through one of the potential solutions to this. So the visible symptom, what is it we can actually see today that says that something is wrong? And to be honest with you, the best sign we have is totally unrelated to anything AI-based. Then have a look at our build pipelines. How often do we see build pipelines where there's just loads of like failed build after failed build after failed build? If you work on probably any complicated stack, but especially if you work on web, because web tests are particularly bad for this, you've probably come across something like this. And maybe not quite this bad, but you've probably seen something where you get multiple failed builds. And quite often when we get failed builds, particularly when it's because of a test issue, we just click rerun. We don't even dive into, we don't look at the logs to understand why the tests have failed. We just retry it. And if it fails again, maybe we'll dig into it. But chances are we'll actually click rerun a second time. It's probably only the third or fourth time that the build's actually failing, that they go, man, we've actually going to have to figure out what's actually going on here. So that's probably our biggest symptom that there's a problem with how we test. I saw some nodding and some smiling as we went through that. The second thing, which is obviously the crux of the title of today's one, you won't be able to read this at the back, probably in the front or struggle, but this is basically a post on Reddit where someone's talking about doing some vibe coding, and they say, AI is still just so stupid, it will fix one thing and destroy 10 other things in my code. And this guy's basically giving up with this whole thing. And I think in many ways, this is a bit of a glimpse of our potential future, not necessarily the potential future, but our potential future of how we're going to be building software, where we can do some prompt engineering, or dare I say, even some vibe coding. And we have this potential for absolutely massive changes across our code base to come from a single prompt. And if they break everything, in a way, that's actually a good thing, because chances are we spot that. But what happens if they break that one critical edge case your number one customer or your number one user is reliant on, but it's not part of the core funnel? So you don't necessarily spot as the developer, but then a week later, a day later, a month later, however long it takes, you get a really angry email or a really angry phone call from someone saying, hey, I'm trying to do whatever it is, and it's totally broken. That's one of the biggest risks that I think we have with this sort of new agentic way of building software. And how we test and the quality of our tests is obviously one of our big safeguards to protect against that. If you can imagine, if you had a test suite that could run, let's exaggerate for effect, that could run instantly, and it could guarantee you whether or not your entire software product worked properly. Think how that would change how you interact with AI. Think how every time it did something which was absolutely stupid, they would instantly get a failed build that says, no, we can't do that. That doesn't work because you've broken this core thing. If we've got the ability to test quickly and reliably, it massively improves our ability to actually use AI, even when it's a little bit crude in its current form, to help us move forwards. Similarly, if we can write tests in such a way, I'm kind of getting ahead of myself here, but if we can write tests in such a way that not only are we testing the existing functionality, we're essentially using some sort of test-driven development or some sort of BDD style approach where as part of that initial prompt to Claude or Copilot or whatever it is, we say, these are the requirements that need to be met. And as part of that initial build, the first thing it does is basically write those tests. Then every other code change it does is automatically running against the most recent version of that test suite, which includes the changes that it's hopefully going to make. It's pretty transformative. Now, obviously, we're never going to get to a state, well, I say never, maybe in a few years' time, we'll see how technology goes, but we'll probably never get to a state where those tests can run instantly and cover absolutely everything. But we can generally get to a place which is much better than where we can today. But as I say, I'm getting a little bit ahead of myself with that. Traditionally, whenever we've tried to build software, we've come at it from a place of trying to put quite a lot of rigor into how we do things. We'll do things like architectural decision records or system design reviews. We'll do wireframes and mockups to make sure that our front ends look like the way we want them to work. And we do prototyping with our users to make sure we're actually building the thing which solves the problem that they're trying to solve. Now, obviously, for some companies or some teams, some of this stuff's a little bit more aspirational than it is for others. But we generally recognize that if we could, these are things we would like to do because we think it will do a better job for us. We're also pretty good at applying fairly strict standards to some of the things that we do. So, especially in a slightly larger organization, you might have things like coding guidelines. Probably in a smaller organization, you'll have things like linters to try and make sure that we're following a certain style guide and things along those lines. We'll probably use static analysis to make sure that we're not doing stupid things, to make sure we're not using old versions of libraries and things like that. And we'll do all of these things to try and make sure that the stuff that we build is good and is working well. Some of the people that I've spoken to recently about agentic coding have said they basically try and apply that same rigor to how they build their prompts. And one person actually said that when they are working with their team to basically hand over a feature to Claude in their case, to get it to do stuff, they'll spend potentially 2 or 3 hours working with Claude back and forth, basically as an agent, building that context so it clearly understands what is necessary. And then they'll say, okay, cool, go and do that. And it will run, I think 2 hours is Claude's maximum runtime. It will run for 2 hours and then they'll come back and see how it's done. But they will spend literally hours trying to get that initial context up front. And what they find with that is actually, generally speaking, most of the time it does a pretty good job. But obviously, even with that effort, sometimes it does go a little bit wrong. But again, if we could have that code as it's building that running against something that makes sure that it works properly, it's not broken in existing stuff, think how much more useful that would be, because it would almost guarantee that at the end of 2 hours, even if it's not solved the problem, it will know if it's solved the problem or not. It will be able to say, yes, I've done it, or really sorry, mate, it's gone wrong, let's try again. And it would know that, it would be able to tell you that. It's not relying on humans to try and do that. So the way that we build software, again, as I say, has all that rigor into it. Historically, though, the way we build our tests, much less so. And it's kind of weird because we put so much rigor, so much attention into making sure we build the product really, really well. But quite often our tests are something of an afterthought. And in a way, I think this has got a little bit worse over the past few years because we started using AI to try and help us with this. And we wouldn't spend hours and hours writing a big prompt to do that. We'd say things like, write the unit test for this. And then we'd leave it and then it'll produce some stuff and we'll go, sweet, they look like tests. Commit, job done. So again, I can say it makes us have these tests that quite often will be unreliable because they're not necessarily terribly well written. But even if they are technically reliable, they're not necessarily actually testing anything. We've probably all come across tests in our code base that when you actually look at them and you go, this test will never actually fail. Like, it's not actually doing anything here. You read between, the 20 lines of code and you just find something in it where it's like, it's always going to return true. It's always going to pass no matter what happens. And I think we've definitely got a little bit worse with that. But as I kind of touched on, we can't blame this on AI. This is a long-running problem, and also arguably, given the quality of testing out there generally is quite poor, obviously all of our training has been done on poor quality stuff as well. So I think to some extent, tests are probably the area which is actually coming off worse from an AI perspective, which is kind of funny because I think it's often the thing people say, oh, it's really good at Copilot's amazing at writing tests. A little bit skeptical of those claims. But as I say, we can't blame AI for this. I've got an example of some code here. This is based on, it's not copy and paste code because then I'd be legal trouble, but it's based on real code in a real code base. And some Cypress tests, if anyone's ever used Cypress. And we can see it does everything that we say we should never do in code. We've got hard-coded strings. We've got magic numbers. We've got code, which is copy and pasted from one line to the next. And quite frankly, it's kind of gibberish. Like, even if you are close enough to the screen that you can read that, you're probably not totally clear on what is actually going on here. Some of the lines probably make some sense, but anybody have any idea what this is actually testing? Can you imagine what product this is? Probably not. And this isn't something which is just like one sloppy team or one sloppy company. Some of these things are actually encouraged by the Cypress documentation. And up until relatively recently, I think earlier this year, one of the things in the Cypress documentation actually encouraged the use of a hard-coded wait. So basically the equivalent of a thread.sleep. That was actually in the documentation to do that. Well, it's no wonder our pipelines are constantly failing. It goes far beyond just the lines of code, though. It's a really deep sort of systemic problem with how we think about testing. And in a lot of ways, I think we can liken it to the earliest cars, where imagine a car today, you've got maybe like two pedals, one that makes you go faster, one that makes you go slower. Super simple, right? But go back to the early 1900s and you've got a Ford Model T, it's got three pedals, but not a single one of these is for the accelerator. One of them is like, do you go backwards or do you go forwards? It's not gears, it's just purely backwards or forwards. Gears are, I think, one of the ones up there, or maybe that's one of the other pedals. But super complicated. And you almost need like 3 arms and 3 legs, plus a degree in mechanical engineering to actually make these cars go when it's like that. But that's basically what our tests are. We expose all of this complexity, the final layer, to our developers. And then we have the audacity to be surprised when the tests don't work, when our pipelines go red, or when bugs slip through to production. And as I say, as we start moving towards more AI use, this problem is only going to get worse for us. I think it's really interesting because I don't really anticipate a future where software engineers don't exist. I don't really see that happening, from sigh of relief for most people in the room. But I don't really see that happening. But what I do see happening is a world where the job of a software engineer ends up being quite different to the job that it is today. And this is not something that's new to the tech industry. If you think back, if you were a web developer 10, 15 years ago, you would build a website by starting with a blank page. If you're building a website today, you start with some sort of boilerplate. You use Angular, you use React, you use Vue, whatever it is. And I think it's a kind of similar migration where the skills that were necessary 5 years ago probably aren't going to be the same skills that are necessary 5 years from now. I think there'll be a lot more emphasis on things like systems thinking. I think there'll be a lot more emphasis on things like scalable architecture, because the reality is these tools are relatively good at producing code, especially in relatively small snippets. Don't think we can quite give it the massive prompt yet and say, just build Google for me. Don't think it would do such a good job at that, but a relatively controlled prompt to say, I want to have a thing which does this thing, it does a relatively good job with. So I can definitely see that shift from happening. And I think part of that sort of systems thinking piece is going to require us to think more about things like testing, things like static analysis, the things to basically make sure that when our agent runs off and does its thing, it can keep itself honest. So I want to talk a little bit about a project that Alakbar and I did in one of our previous companies, where we set out to try and solve this testing problem, to try and basically never have a pipeline that looks like that one at the start. That was a real pipeline, by the way. That's not an illustrative thing. That was a real pipeline from that company that we were starting with. And when Alakbar and I were doing this, we weren't thinking about it from the perspective of AI is coming, and therefore we need to build tests that will work with that. But with the benefit of hindsight, that is actually kind of what we did. And as we set out, we had a few goals that we wanted to make sure we could achieve with it. Tests had to be basically easy, fast to write, easy, little time to maintain. They need to be low effort for existing and new engineers to learn. They have to be stable, reliable, and scalable. Now, it's interesting because, again, if we think about this from the perspective of when do we get the best success out of AI, it's usually when these conditions are true. When something is easy for it to write, it's more likely to do a good job of it. If it's adding something to a nice clean code base where there's lots of conventions already established, it does a pretty good job of doing that. When things don't take much effort to maintain, again, it's good with that because that means we can kind of keep progressing forwards with things. Don't touch on it quite so much on this slide, but if they're fast to run, again, it helps with that prompting perspective. So diving into some of the implementation, we were building web tests. I think we've got a mix of kind of web developers in here. I think we've got some back-end people, over some AI engineers as well. I'll talk mostly to web, but you'll find that the common principles will apply across each. One of the first things that we found was that we had been using Cypress. And Cypress was basically irreparable for us. Not because Cypress as a tool is broken, because a tool is only ever as good as our use of it, but basically because we'd gone so far down a path as a company that to try and get back to a good place was going to be really, really hard. Like just trying to iterate from basically a disaster zone to a nice, healthy place, really, really tough. So what we decided was Playwright's probably a better tool anyway. Playwright's another browser automation tool. Probably a better tool anyway. And if we can start with a bit of a distinct line in the sand where we say, this is the old way over here. We don't do that anymore. Here's the new way. Here's the promised land. It's green and there's sunshine and rainbows. It just kind of gets us into a different mentality when we're writing tests. And I think that's the sort of general principle you could apply with any sort of change along these lines. We also generally found that the Playwright actually was a better tool. It offered some better features in there just because it's a bit more modern. And again, I think especially as we think about building software today, which is going to see us going into the future, I think it's worth us being quite deliberate and sort of explicit with our thinking of, are the frameworks we're using actually the ones that we want to have in 5 years' time? Or is now the time when we actually want to start investing in maybe a little bit of tech debt repeal or just sort of reinvigorating some of these things? Because I could argue that AI is only going to get better. Hopefully it's only going to get better. And I think we're at a point just now where nobody really knows quite how to get the best out of it. I'd say you look on LinkedIn, you'll get some companies you're claiming they are, but then 6 months later, the product looks exactly the same. So a little bit skeptical as to whether or not they really are going 100 times faster. But I think in a year or two, we'll have a bit more evidence for how they actually can go faster. We'll know how to do good prompts. We'll know when we should use it and when we shouldn't. And I think there's a reasonable sort of train of thought where you could say, now's not the time to be doing that stuff. Now's the time to get ready for once we have those answers. So modernize your frameworks, pay off some technical debt so that when we actually know how to use AI well, we're ready for it. We can actually run forwards from that point. So get those foundations in place just now. And for us, I think Playwright basically offered that. As I said, that wasn't the way we were thinking at the time, but looking back retrospectively, I think actually for that reason, or for that justification, is a really, really good approach. We also invested quite heavily in those strong foundations in general. So making sure that we weren't cutting corners, making sure that we got good examples in the code base, which again, from the perspective of similar to what Alex was saying before, if you can give your AI some prompts and say, this is what good looks like, this is what a good answer to that question is, it helps to give other good answers in the future. So by making sure your code base is basically gold standard to begin with, it makes it much easier for then your agents basically to replicate that going forwards. And as part of that being, we were really, really picky with our pull requests for that first month or two, just to make sure we held as high a standard as we possibly could. The test architecture that we landed with also definitely lends itself to a more regenerative future, which again, was not planned at the time, but with hindsight, we got kind of lucky with that one. We went with a page object model. Page object model, if you're not familiar with it, relatively well-established pattern for web front-end tests. But yeah, isn't used anywhere near as much as it should be, especially not in companies where you're maybe less likely to have dedicated test engineers, tend not to go for this approach. But basically what it offers is really clean separation of concerns. And it means that you can have some sort of abstracted logic in your page object model, which can deal with how do we actually interact with, for example, a page on our website, or if you're building an ad, it could be the same thing. What are the locators that we need to use? How do we identify that field is the text box? All of those sorts of mechanics. The logic for that gets captured in your object model, which then means that your test definition is basically like a test case. It's like an old school written test case of, as a user, I'm going to click this button, I'm going to do this, I'm going to do this, and then result is X. And again, you have a really clear separation of concerns there, which lends itself really nicely to building some of this stuff into your prompt. And you could actually say to Claude or whichever tool you're using, I want you to solve this problem. Here's the test case for how you're going to validate it. That is your test case for how you're going to validate it. And depending on what you're building, all the underlying stuff might already be there. You won't necessarily have to do any other changes elsewhere in your code base, because if you're adjusting existing functionality or just making small changes, small additions, your page object model, your other things that are there, potentially contain all the information that it needs to be able to do that. If it doesn't, that could be a great thing for you as a software engineer to actually focus a bit of time on, so that when it runs these tests, everything's there for it. I'm not going to go into massive detail on each of these things, but just to kind of give a little bit to bring it to life. So we've got an example here of a page object model, which is basically simulating a login page. So you can see we've got some really simple stuff. We're defining a few locators at the top, like here's our page, This is the username, the password prompt, the login button. This is an error message. And then we call out how those things will actually be identified. So usually on web, it's with things like IDs or CSS classes or something along those lines. And then we get a little bit of logic for how we might interact with them. So in this case, we've got a function called login. We pass it a username and a password. And what that function will do is it will fill in the username, fill in the password, and then click the login button. Obviously, really simple example. But if you imagine something like a calendar control or like a date picker, if you think how easy it is as like one human to another to say, I want you to choose the 13th of January 2026 on that calendar. Really easy to say, but if you think about all the interactions that a piece of automation would need to go through to do that on a typical calendar control, they would need to click on the field. They would need to click on the year. It would have to then click on the next year. And we have to click the next arrow to get to the next month. It would then have to click on that, and then maybe it'll have to click submit. And all of that complexity of how you interact with that calendar control can be wrapped up here. So you have it defined once, and then your test definition is as simple as the human-to-human version of click on the 13th of January, whichever day I said, 2026. And again, it just makes it so much easier to maintain and to reuse that stuff. This is what that test definition might look like for that login page. And I'd say it's just like an old school manual test case. We define our login page. We say we're going to go to it. We say we enter our username and password, in this case with an invalid password. And then we expect the error message to say invalid username or password. So that's simple. And again, from an AI perspective, this is a really feel like it could easily write this and it's going to get that perfect pretty much every time. Because it is nice and simple. And as I say, we've got lots of good examples for it as well. I kind of touched on this already, but I think the importance of thinking test first, I think is only going to get more significant as we move forwards. I think things like TDD and BDD, which have been around for 30 odd years probably since they kind of became mainstream, certainly mid-90s, XP was kind of at its peak. I think we've all heard of these things, but I'm interested actually, like, very genuine show of hands, has anybody actually properly done test-driven development? Probably not, but you've heard of it. And I think it's one of these ones that I think we probably mostly recognize how it could be useful and why it could be useful, but actually doing it in practice I think is a real challenge for us. But I think going forwards, techniques like these could be incredibly valuable for getting the most out of AI tooling. And again, it's a fairly obvious one, but we often struggle with it. Maintenance, updating, all this sort of stuff, like it needs to be part of your day-to-day. If you don't keep on top of your tests and likewise your linting logic and your static analysis and things like that, if you don't make that part of your day-to-day work, it will just get exponentially worse over time until you get to a point that basically you can't do anything because the builds are constantly failing. Or in the case of things like linters, it becomes so detached from how you actually write code that it's basically a waste of time. So you screen every time, even if something is bad. The other thing that I think is worth noting is just the observability around things like testing. And I think probably for most of us, if we've got a product in production, we probably use some sort of tooling like Datadog or PostHog or something in AWS to basically give us some sort of observability for, is our product, whether that's from a business perspective or a sort of engineering or service perspective, is it working properly? We'll have something that we'll look for, like are our error rates going up? Of something that basically does some sort of basic health check and says, is our product actually available at all? We might have something which monitors conversion rates or something like that and pings us if something changes. Hopefully that sounds fairly familiar to people. I'd argue that our tests are our product as well, and we need to have similar monitoring and alerting around them. Because otherwise, this sort of scenario here where you have like one person on your team who goes, pipeline feels a bit flaky just now. And someone goes, yeah, I suppose so. Kind of want something a bit more actionable than that, and we also don't want to have like app person constantly having to do that stuff manually. So just keep this rail from behind level, but this is one of the things that we invested fairly heavily on in this previous company, where we wanted to make sure that we had data which basically told us are our tests working as they should be. And so we pushed all this stuff into a tool called Plandeck. Plandeck is a software engineering intelligence platform. And it's a great way of visualizing not just data like this, but also to pair this data alongside other things like perhaps our cycle time. So if you've got a really flaky test and your pipeline's constantly breaking, chances are you're developing more slowly because you're constantly being blocked by your pipeline not working. How many people, actually, show of hands, have had a problem like that where as an engineer, you've had something in your code base which has massively slowed you down and you've struggled to convince a product manager or some other business person that it's worth investing time in that? Show of hands. three brave people. I don't believe the rest of you. I don't believe you're a professional software developer and have never had that struggle. You're incredibly lucky if that is true. One of the great things with platforms like this is you can take data to these people and you can say, look, here's the problem. You can see over the past 6 months, let's just pretend this is flakiness. It's not, but let's pretend it is. Over the last 3 months, our flakiness has massively gone up. And here's this other line that shows how long it takes us to now build new software, because every time we try and make a change, the tests are breaking and it's slowing us down. Therefore, we need to spend at least some effort in our next sprint or whatever it is we're working to try and repay some of the steps and fix some of these problems that we've got and make things a bit healthier. As it is with this data, it's actually the blue line at the bottom is our flakiness, sitting around about 0 point something %. Flakiness in this case is basically any test that was automatically running as part of the pipeline. So from an external perspective, like if you were a developer, a flaky test in this context wouldn't ever actually fail the pipeline, because flaky basically means that we'd ultimately pass on with a retry. But we kind of wanted to work towards a zero tolerance of that, where any test that isn't deterministic, i.e. we don't know for sure how it's going to perform every time, is a problem for us. And we basically worked on the basis that if that number ever gets above 1%, that's like a production incident. Like we have to stop everything. We have to swarm on this right now. We were aiming for as close to 0% as we could get. Generally sat around about 0.1-ish %, which is pretty good. Our purple line is showing how long our tests were taking to run. So we can see we started this project a little bit back here. So the first data point in the graph's a little with a line being at 0, 0, but started back here. As you added more tests, this has gradually increased in time to just over 5 minutes at this point, which is not terrible for tests like these, because these are like end-to-end system tests. They're basically that final sense check the application's working properly. But it does mean that if, again, we were running something through Claude or through Copilot with this, it means that we'd have to wait 5 minutes to get that feedback that things are working properly. And at that point, I would say that's now starting to get a little bit too long. So having that visibility of how long these tests are taking, really key part of that. Obviously, flaky tests as well. You don't want flaky tests if they're the thing which are making your AI decide whether or not it's done the right thing or not. Like the AI needs those tests to be deterministic, because it itself is kind of random and chaotic enough that it needs everything else around about it to be reliable. The orange line at the top, this is our test pass rate, and obviously test pass rate both factor in many things, including things like environment stability. One of the challenges we had in January was we were relying on Amazon Spot instances for our test environment, basically, and we were just getting a lot of things getting killed. It's like we were just in the sites of like AWS, basically. Every time someone else needs a EC2 instance, we're going to kill those guys once, and it really hit us hard. And this was actually one of these ones where towards the end of January, start of February, he said, we're now actually spending so much time diagnosing these things caused by Spot instances going down. We're probably not saving money by having Spot instances anymore. We're probably actually better spending the extra tiny little bit of money to get more reliable instances. And therefore, actually, well, as a business, we'll be more productive as a result. And then having data like that makes it a little bit easier to have those conversations. Because otherwise, it's really hard to justify why you spend an extra couple of £1,000s a year on a test environment. But this basically is the data for why that could be useful. The other nice thing with metrics is it means that when something happens, we can help to figure out when it happens. So we merged a pull request on the 24th of March. It caused a massive spike in our flake rate. Took us a little bit of time to actually figure out precisely what it was. It's not the best example from that perspective, but around about here, we went, actually, something is clearly not right here. We went back, had a look through the things that emerged, and found a really suspect PR that went in on March the 24th. It was a product change. This was actually a genuine issue. So although the tests were now just flaky and not just failing, it basically introduced a race condition, which, because we trust our tests and we know we don't want them to be flaky, even a race condition we were able to find. But it also meant it wasn't a quick fix, because we had actually made a product change for our customer that had introduced this. So we couldn't just roll back. We just have to fix forwards, which is why it takes a little bit of time. But again, I mean, kind of see at this point, fix goes in, flake rate drops right down. Which again, from the perspective of being able to justify to ourselves, to our product managers, to our business stakeholders, wherever it could be, why it's worth us investing in these things, this data is a great example of how we can do that. Very quickly, some other benefits that we found. Helps us find things that were going wrong elsewhere in our products as well. we had some canary checks basically. Whenever we just before we released their production, so things were out in the production environment, but not yet actually live to production traffic. We'd have a canary check that would basically make sure the things look healthy, and just every so often, that check would fail. But we'd look at it and be like, "That's fine. It's in itself a little bit flaky." And what we actually found, because we saw a similar issue in our end-to-end tests, is that we were hitting at like a really weird bug in a Postgres library that basically meant that when our tests were running through some stuff, when our integration tests were running through some stuff, they were actually deleting data from that database. Which then meant when the canary went along to make sure things were fine before everything got switched over to the prod database, it would go, "No, stuff's not here, something's wrong." And basically because of a bug in some obscure Postgres library we were using. And we were able to find that, track it down. Fantastic work by the engineers to find that. And basically that was what we'll sequence our tests a little bit differently to try and make sure that doesn't happen, whilst also hoping that at some point they gets fixed properly. Was also a great way just getting people between teams talking as well, because it meant whenever something was going wrong in those test environments or in production, if we ran them there, it just got people talking because we recognized that something's clearly not right with this. You wouldn't just have your front-end developer going, the end-to-end tests are flaky, that's just how it is. They would say, "Hey, the back-end developer, we've got this issue that's come up. It looks like we've got a 500 response from this endpoint. What do you think it could be? Like, is there something in the logs?" And we'd actually just communicate on these things way more than we ever otherwise would have. And just final thought, just on some lessons learned from this. As I said, at the time, didn't realize it, but this is exactly what I would do going forwards if I was trying to build an AI-driven software team. Didn't realize it at the time, but looking back, 100%, I think this is a sort of two birds with one stone type solution. We also found, or one of the key lessons for us is, when we were talking about tests as an engineering group, we were pretty well aligned on what tests were doing, what our desired outcomes were, why investing in end-to-end tests made sense. But it wasn't until probably a couple months into this effort that we started to realize that many of our stakeholders, product managers, for example, don't necessarily understand what we're doing here. And that meant that when we had other things, like maybe like an engineer was struggling to write unit tests for something, they would talk about that in a daily stand-up saying, "I'm still working on the test for this ticket. It's really hard because we're trying to mock out this library or this thing or whatever. It's really taking a long time." The product manager would just hear tests. The tests are slowing us down. And obviously at the same time, we're investing quite heavily in some other tests. And it was one of these ones where it took us probably an embarrassingly long period of time to actually realize that we're not all on the same page with this. But I think it was just a really nice reminder that whenever we're doing anything technical, and I think with the advent of AI and the amount of things we could be doing in that space, just to over-communicate, to be really, really clear with everyone, this is what we're doing, these are the challenges, these are the parts of the code base it's going to hit, and just be really explicit in over-communicating to make sure that everyone understands what you're doing, because it's so easy for somebody to be a little bit lost and then for that to continue down the line, and then get to that point where it's almost too awkward for them to start asking questions. So not directly related, but definitely a lesson, I would say, is learned from that. And that is everything that I had to share today. So I just want to say thank you very much, and happy to take any questions that anybody has. Go for Matt.
I do have a couple of questions actually, so try to work through them. Thank you for the talk, because this is quite timely in a contemporary world where code generation is increasingly popular. I think it's going to be part of our workflow, so it's not going to go away anytime soon. You mentioned about test definition to be able to provide more context to LLM when writing tests.
Yes.
I mean, like from that point of view, I feel like if I can quickly come up with test definition, I can as well write the test myself, right? So how reusable or important would the prompt be at that point? Because if I'm writing test definition level prompts for LLM to generate a test for me, right, that's going to be like one of, like, how do I get to reuse that? Because sometimes given the logic, it might not be the same with other part of your code base, right? And so I'm just wondering, if I was spending my time writing test definition, right, I could as well just write a test, because it's going to be more like providing the full details of what test say.
So I think that's probably what I would say is actually the right thing to do. And I think if you were to write that test and make the context of that test part of your prompt as well, so that essentially following that TDD model of saying, here's the test, it's currently failing, the test is in the code base, now Claude, go and work your magic. I think that's probably where you would get the biggest benefit from it. That being said, similarly to how when we do TDD, we might actually discover as we're implementing things, we might discover tests we never thought about writing at the time. And I think that's when, again, I would hope that AI would be able to add additional tests where necessary. Like if it's simple example, if it's getting some sort of input from an input box, it might go, we need to make sure we're handling Unicode characters properly. And we don't already have a test for that, so I'm going to add that test in to make sure that when I put an emoji in, it works properly. Incidentally, like every website breaks if you put emojis in. It's hilarious. But yeah, I think just that ability to easily add things as it goes through, I think is where the value is, or where part of the value is. But the core part, I would say, write the test up front and then use that as part of your prompt for AI to do its thing.
Okay, cool. So you also kind of emphasize on end-to-end test, right, which is some sort of integration test to see that all the components are actually connecting properly with each other. And I mean, there's a bit of test coverage, which is very important. So if we are heading to a world where you want to prioritize end-to-end testing, then what does test coverage fit into that workflow? Is this something that you, projection-wise, feel like it's still going to be very important, or just ensure that the components connect together?
Yeah, test coverage in general, I think, is a little bit mythical as a concept, in that you can get a very almost regardless of how you measure it, you can get a very high number on test coverage without really testing terribly much stuff at all. And I think in the most simple way, like if you look at lines of code as a way of test coverage, and through what percentage of my code was executed by these tests,
I think it should be more like covering the entire logic. Like,
yes, I think if you can in some way map between, for example, number of like features or maybe some sort of like path analysis type thing, you'll get slightly better stuff from it. But even then, it's a really, really abstract thing. Like you could say, oh, we've got all of our features are covered by automated tests, but does that mean all the different inputs could be covered by them? Probably not. Are they covered on desktop and on mobile? Are they covered on iPhone and iPad if it's a mobile app? And I think it's a little bit mythical, I think, with test coverage in general. I don't really like it as a metric. But I think if you take a slightly more qualitative take on it and say, we want to make sure that every core feature, every core journey through our app, through our website, is properly covered to the point that if it breaks, we're about as confident as we can be that we're going to catch it. And I think if you can sort of do that, and I'd say it's less quantitative, it's less black and white than a more traditional test coverage metric would be. But I think if you've got that and that's what you aim for, I think that puts you in a pretty good place. I'm not sure if I answered your question or if I just woke.
So, because from experience, right, I was part of a team where if you add in a new feature and it doesn't meet a specific test coverage, the pipeline is going to reject your feature. So you're not going to be able to just combine that and then deploy. So it just becomes, should you prioritize test coverage than end-to-end testing, because that is being kind of covered separately.
So I think if the finger building lends itself to like a test, like a quantitative test coverage measure actually being useful, I think that sort of gate in the pipeline, I think, makes a lot of sense. And set the number high with it as well. Like really, if it's less than probably about 90%, almost regardless of what that's 90% of, like set it at least that. I would argue in a lot of cases, you can probably get sort of 98% plus, especially at a sort of unit and integration test level, because you're mocking all the complicated stuff out, like all your libraries and stuff, you're mocking out anyway. So set it high if your code base lends itself to that, and use that as a way of making sure that your agents are keeping themselves honest. And then when you're doing your code reviews on the stuff that your AI agents are producing, focus on the tests more than anything else, because they are basically your last line of defense against stems.
I promise this is my last question. Actually, go for it. So for you, showed us the picture of a pipeline, the failed ones, and I mean, And when I saw that, I had a bit of PTSD because it looks familiar, So, but are we heading towards, from your own point of view, are we heading towards a development flow where we have LLMs integrated into our pipelines that some of these errors will actually be spotted, and maybe probably you have some sort of intubations that could detect and fix on the fly or stop the flow, and then maybe debug and then send you what the suggested solutions could be so that you can easily fix that error on the pipeline and then get your deployment into live.
I think we could, but I also think this is something where I don't think you need an LLM for that. I think you just need reasonable sort of old school monitoring, alerting around those things. I think one of the problems that you often have with especially test runners, but to us so much stuff in your build pipeline is it logs to like your terminal output, like to stdia, and you use this massive wall of text. And if you troll through it, somewhere in amongst that, you'll get a warning for this thing, and maybe not an error, but a similar sort of alert message over here. Or if it's your test, you'll get told this test was flaky, but it's okay, it passed 2 times out of 3 type thing. But they're not exposed anywhere. And unless you're sitting down and reading through your build output every time, you're not going to spot those early warning signs that something's starting to go wrong. I think it's quite often what causes pipelines like that is we ignore the warnings because we don't see the warnings, and then eventually it gets to the point where just everything's broken, basically. And it almost feels like it literally all breaks on the same day sometimes. It probably hasn't. It's probably been that sort of slow burning fire. I said that meme, the sort of this is fine thing with the fire behind. It's kind of like that where you just suddenly realize that, like the Ruby is on fire now. There is a problem here. And I think generally we just have to get better visibility of our build pipelines. I think you probably could pass that log into an LLM and have it look at those things and do it that way. But I don't think you need to. I think we can solve this with old school things. But that being said, I think there's probably is some stuff that I think we could do along those lines that probably would have been doable 5 years ago as well, but isn't just so much easier now. And one example that I've got is end-to-end tests. Generally speaking, they're quite slow to run because they're naturally, you need pretty much a full stack for them, pretty much. Otherwise, it's not end-to-end. And they're usually going through multiple steps. So they're not quick. They will usually take at best several seconds, potentially 30 seconds, a minute, maybe even longer for a test to run. In contrast to our unit tests where they might take a couple of milliseconds to run. So one thing that I think your LLMs possibly could do is to look at the changes that you're making, look at the most like high risk or sort of high impact parts of your product from the perspective that if it breaks, this is a problem, and figure out on the fly what tests do I actually need to run off the back of not just this PR, but also like the Jira ticket or the Figma design or whatever else it is to understand what the likely blast radius is. And I think that sort of selective running of tests, I think, is something where it probably could actually be useful. And what I could kind of imagine with that is maybe something where whether like you as a developer or whether it's, again, I'll pick on Claude, or whatever AI agent you want to use, when it's actively working, it could run that really small subset of tests around the things that it thinks is likely to have broken. And then potentially in the pipeline, it runs them all, or maybe in the pipeline, it runs some more. But then 5 times a day, it runs this more holistic, more complete set, which especially if you're working in a company where rollouts take a little bit longer, either because you're like A/B testing or you're doing a blue-green deploy or whatever, where you do potentially have more time anyway before it goes out fully to prod. You don't necessarily need all of those tests to run instantly if the probability of them actually finding something is quite low. And I do think there is something in that space where I think some of this tooling could be really, really useful. Thank you. Any other questions? Does it make sense to people? Do people kind of see why I kind of am joining these talks, or does it all just sound like nonsense? Be honest. Thumbs up and nodding. That's good. You're very polite. Right? You do actually see it. Awesome. Well, Henry has any other questions?
To be honest, like I want to say that like the way people develop applications now, they became so used to like code generation, like and VS Code extension, like how it's called, like how about the name?
Copilot.
Yeah, Copilot. So like you have all of this all together, like, and it generate the code like in such a drastic, like rapid, like change. So the problem is like, and the thing is, people think that like when I generated it, it should be fine, it should work, and like they don't spend enough time at all, like try and even test it manually when I'm creating a pull request, which is like from what I'm seeing, like for me, like it's a big problem, like when I'm trying to review their code because they skip a lot of like use cases very often.
Yeah.
So I can say that putting like more effort, like and making it a part of pipeline and just restricting all of those team members like into all of those rules makes this so much like sense here. I'm just curious, like how much would cost like that tool that visualize it?
Plan Deck. So Plan Deck is they have two kind of product tiers. One is designed more for sort of smaller teams, smaller companies, that is more about kind of live product feedback rather than necessarily some of that stuff. And I might be wrong with this, but I think that's basically free. I think there's a very generous free tier with that one. And the sort of the enterprise side of things, all I would say is if you're genuinely interested in Plan Deck, tell them I sent you their way. You will probably get pretty favorable pricing. It's one of these, like, I know that this CEO of Plan Deck fairly well, having worked with Plan Deck and him for many years. He has jokes on many occasions I should be on commission, but I promise you I'm not. But yeah, I think it's one where it's the licensing is based on like the users and the data. So basically, in a smaller dev team, it will cost less, and the larger dev team will cost more. But it's not based on logins is the key thing. So you can work on the basis that just the manager will have it or something like that. Like it is kind of based on that. What I would say is that it's, for me, the justifying the ROI of it's quite easy because you don't need to get much better or much more effective as a development team or as a company to get that sort of repel back. I can't even think off the top of my head numbers wise what it is, and it is a sort of call for pricing type thing, but I think it's actually not that difficult to justify when you think about it. Genuinely say I sent them, their way, and yeah, you might get special pricing.
I hope they pay you for that.
I have a small philosophical question. So we are like currently
Smart philosophical. Is there such a thing?
we currently at the point when like LLMs or coding agents are not ideal. Yes, but still, for example, I use Claude every day, and Claude can produce like a lot of code like in a couple of minutes. And to use like this code, just like to bring it to pipeline, I need to create a pull request. So I need to review the Claude code before even like making a pull request. But at some point in time, let's imagine that they become like good enough, and they can produce potentially much more code than we could review. It's the first one. And second one, they could produce much more code than we potentially can test. So what is your opinion how you could take out code?
I think we're kind of there today, to be honest with you. I think the amount of code that it can produce in such a short period of time, it's not necessarily beyond what we theoretically could review, but I think it goes beyond what most engineers are willing to review. It's that classic thing of if you do like 100-line PR, you'll get like 10 comments on it. Do 1,000-line PR, it's like, looks good to me. I think we kind of already have that problem with it. Which is why I think things like linters, things like the static analysis, like you really need to make sure that's like top tier. I was doing a side project a little while ago and basically trying to exclusively vibe code, which is the most painful thing I've ever done. But it was an experiment. And one of the things that it did, it produced classic thing, huge amount of code in a short period of time. And I looked at it and I was like, you've got a load of Z indexes in here to layer elements in the UI. I don't really like that. That's not a terribly scalable way of doing it. Can we sort of rejig our HTML, keep everything nice and clean and semantic, and make sure the natural order in which things are going to appear is going to be correct? And also it's like, yes, you're absolutely right. We should do this to a high standard. Like, sweet, it gets it. And then it fetches like 3 of the issues and like leaves the rest of them. I'm like, no, like I told you, get rid of the Z indexes. And this thing's like classic. Yes, you're 100%. You've got to get rid of these. And again, it fetches like 3 more, but then breaks one of the previous ones. And I think there's such a solid example where just if I had a linting rule that said basically don't allow Z index, then it would instantly fail on that, and it would probably do it properly without me having to worry about anything at all. And I think we've really got to invest in things like that so that when inevitably we cut corners, even ignoring the possibility that it could produce a million lines of code in 5 minutes, even ignoring that extreme, just with where we are today, we're already at a point where we're not going to review it as much as we would say we would, and we won't. Like we're human, we don't do that. And I think that's when we really need to rely on these things to try and make sure that when we do skim through it, the likelihood of there being things that we miss is just that little bit lower because we're trying to cover as much as we can. I think it will be a long time before we get code from it that we genuinely could just send straight out to production with reasonable confidence that we're not breaching, some basic security stuff or whatever. But it seems unlikely that that time will never come. But I think that's a reasonable way away. Just looking at the quality of what's not just the quality of what's being produced today, but the lack of step, like Yemi and I were talking about, Charlie, the lack of step change from especially GPT-4 to GPT-5. It's pretty small change. Similarly with maybe slightly less so, but similarly I think with Claude as well. I think we're kind of not necessarily at the peak, but we're definitely hitting that plateau with it just now. But I think this is a space in general where even if the current approaches won't get as much further in, let's say, 10 years time, if there's a totally different way of doing this, then it seems unlikely that we wouldn't be able to just get really significant volumes of stuff out with reasonably high standards. But would I want to be like the CEO running the company that does some of these things? Probably not, because you could very easily have a very inexcusable thing go out to production. Because if you've got 100,000 lines of code and one of those is logging a password in plain text, how do you explain to the public that, yeah, we logged this password to plain text in the year 2035 when we've known for 30 plus years that that's a totally unacceptable thing to do? I think that is tricky, and there's a moral angle to this as well. The philosophical one, there's the moral one of at what point are we just being like societally, is that a word, like irresponsible by doing these things. But it's tough because if you're a business that's looking to crack into a new market, maybe you take that risk, or maybe you take that risk and then sell to Deloitte or someone before the bad stuff actually happens.
Yeah, I'm asking because human mind obviously will become a bottleneck at some point in time. And even for example, if I do the TDD, BDD, like I still let the Claude write the test for his own. And I still, obviously, I do 100% of reviews of his code, but still it takes time. And for example, if I remove myself from the chain, a Claude can deliver much faster.
Yeah. There's a really interesting, as a sort of side-based step to this, aviation's a really nice place to look for a similar sort of challenge of a lot of automations come in. It's undoubtedly caused a little bit of erosion of skills in pilots as well, but just that over-reliance of it. And without going into too much detail, even with the likes of the 737 MAX incidents, there's reasonable examples of things that maybe 30, 40 years ago, a pilot would have known how to do. They would have spotted things differently that I think today we struggle with more because there is so much automation. Like when you're piloting a plane, also not a pilot, but when you're piloting a plane, there's so much stuff that does take care of things for you, does make your life so much easier that I think naturally a degree of complacency comes in. The same is true when we're driving cars as well. We don't think about things the way that we would have done even ignore the Model T thing, but even 20 years ago where you didn't necessarily have traction control or ABS or whatever quite the same, whereas we're very reliant on those systems just now. But I think aviation is an industry that in this regard is probably a couple of decades ahead of us. And I think there probably will be some lessons that we can take from them in terms of how do they monitor an aircraft so that when something does go wrong, very surprisingly, they're actually in a position where they can detect it and respond to it appropriately. And how do they stay engaged on a long haul flight and all that sort of stuff. So I think aviation is one. I dare say there's other ones as well. But yeah, I think there is a challenge there, and humans aren't good at monitoring things like this. We get distracted far too easily. We get complacent far too easily. And yeah, I can very much see that being a problem for us. And as I say, it will be the most embarrassing thing when it does happen. It will be like passwords being logged to plain text or something like that, or you'll have some GraphQL endpoint somewhere that's somehow managing to expose some data that it shouldn't because it just sends all the stuff to the front end. And sure, the front end only displays that part, but all of it was sent. And if it'll be something like that, that there'll be some poor engineer somewhere so like horrifically embarrassed that it was their change, as it were, like it was them to click the button. But I think it's one where it probably could happen to almost anyone with the way things are going.
They'll probably be typing with ignition later.
Yes. But they won't have to type it. It'll come out automatically. Yeah. Awesome. Any final questions or thoughts? Any thoughts from anyone else in the room on this as well? You've heard my thoughts on it, but we've had some great questions. Anything else anyone would add?
Hey, thank you.
Awesome.